कंसेप्ट क्लियर लर्निंग में आपका स्वागत है। गाइज, अगर वीडियो आपको हेल्पफुल लगे तो लाइक करना, शेयर करना और कमेंट करना।
It's a warm, sunny day. The icebergs have started to melt.
Water becomes solid at very low temperatures. Ice melts and changes back to water when the temperature increases. This phenomenon of matter converting from one state to another is known as interconversion of the states of matter. In this lesson, you will learn about the interconversion of the states of matter. You will also learn about the effect of temperature and pressure on gases. At the end of this lesson, you will be able to affects the three states of matter. Explain the concept of latent heat. List the factors that cause evaporation, of condensation. Describe the concept of sublimation through an experiment.
I don't understand. Why does ice melt on a sunny day?
To understand the melting, let's perform an experiment. Take about 150 grams of crushed ice in a beaker and place it on a tripod. Next, suspend a laboratory thermometer into the ice in the beaker. Then, heat the beaker with a Bunsen burner. Remember to note down the reading of the thermometer every half minute. Observe that the thermometer remains at 0 degrees centigrade till all the ice melts. The thermometer shows a rise in temperature.
That.
Heat energy is used up in changing the state of matter. In our experiment, the heat is used to increase the kinetic energy of the particles of ice to the extent that they break away from the rigid lattice structure of the solid form, ice, and move around freely to form the liquid form. So, until all the ice has melted, the heat absorbed does not raise the temperature of the mixture. This heat, which does not raise the temperature of the body, latent heat. The latent heat of fusion for any substance is the amount of heat energy required 1 kilogram of the substance from its solid state to its liquid state at the same temperature. Getting back to our experiment, let's continue to heat and note down the thermometer reading every minute. The water has started to boil, rising from its surface. Also notice that the temperature has stopped rising. It is now steady at 100 degrees Celsius.
Amazing. Why does the temperature not rise further?
Water boils at 100 degrees Celsius. Temperature. It changes from the liquid state to the gaseous state. Just like in the case of ice turning to water, this change of state also requires latent heat. When 1 kilogram of a substance in the liquid state changes into its gaseous state at the same temperature and at standard atmospheric pressure, the heat energy used up is known as the latent heat of vaporization of that substance.
Ah, I see. Every time matter changes state, latent heat is taken in or given out. But do we really need to heat things to change them from one state to another?
Not necessarily. For example, seawater absorbs the heat from the surroundings and vaporizes, leaving behind the salt that This process is known as evaporation. Thus, a process where a liquid changes into vapor at any temperature below its boiling point is called evaporation. Evaporation occurs only at the surface of the liquid.
Tell me more.
Shallow quarries or bunds are built near the sea. The shallow bunds have a large surface area for water to evaporate quickly, much like the clothes that you spread out on a clothesline so they dry faster. Water from these bunds evaporates, leaving salt behind. Salt is collected and refined before use.
So, the rate of evaporation depends on the surface area. What else does the rate of evaporation depend on?
Well, evaporation also depends on the temperature of the surroundings. You know that the clothes dry faster on a sunny day. Thus, evaporation is faster at higher temperatures. You're probably thinking that dry quicker. You're right. Because of the particles of water quickly, reducing the amount of water vapor in the surroundings. You know that water evaporates, but what happens after evaporation?
The water condenses and we receive the same water in the form of rain.
Yes, let's begin with an example, which is very common in our everyday life. Let's take an ice-cold water bottle. Leave it on the table for 2 minutes. Observe water droplets on the outer surface of the bottle. These water droplets are condensed water vapor present in the air around the cold bottle. The process where a vapor changes to liquid is called condensation.
Can I convert this liquid into a solid?
Of course you can. Watch this. I'm going to place the same water bottle in the freezer and remove it after a few hours. The water in the bottle has frozen. A liquid converts into a solid when the temperature is lowered below its melting or freezing point. The process where a liquid converts into a solid is called freezing. Sometimes, a solid directly converts into a gas while heating, without changing into liquid. Let's do an experiment. Take a few ammonium chloride crystals in a china dish. Cover the china dish with an inverted funnel. Then, plug the open end of the funnel with cotton. Heat the ammonium chloride crystals in the china dish. Observe that the solid crystals of ammonium chloride directly change into vapor without changing into liquid. Now, stop heating. You can see the vapors of ammonium chloride settle as crystals on the inner walls of the stem of the funnel. The ammonium chloride crystals can be collected from the inner walls of the funnel. The process where a solid on heating directly changes into gas without changing into liquid, and a gas on cooling directly changes to solid without changing into liquid is called sublimation. Now, let us see the effect of pressure on the interconversion of the states of matter. You know that gas gushes out with a hissing sound when you open the knob of a domestic gas cylinder. In a domestic cylinder, the gas is compressed at a high pressure and a low temperature and is stored in the form of liquid petroleum gas. Opened, the pressure is released and the gas gushes out. However, it's possible only in gases because gases can be compressed. Gases can be liquefied by increasing pressure and lowering temperature. This This principle is used in the liquefaction of air to separate the components of air. To sum it up, the process where matter changes from one state to another and the original state by altering the temperature is interconversion of the states of matter.
वीडियो पसंद आई
गाइस, आई होप कि आपको ये वीडियो पसंद आई हो और आप इस वीडियो को लाइक, शेयर, कमेंट, सब्सक्राइब जरूर करेंगे और आप इसे औरों को पहुंचाने के लिए हमारी मदद करेंगे और आप और जानकारी पहुंचाने के लिए आप हमें सब्सक्राइब भी करेंगे। बाय गाइस।